Hi everyone. Today topic is dynamic programming. So we already discussed two design techniques called divide and conquer and the greedy method, and also discussed some problems used on those methods, right? Those technique. So here dynamic programming is an algorithm design technique used to solve complex problems by breaking them into smaller overlapping subproblems and storing their solution to avoid repeated calculation. This is the important thing. So no need to calculate the same value again and again. One time you find the value, then store it, then use that stored value for the future calculation. This is the main idea behind this dynamic programming concept. Okay, so this is the basic idea. So initially we saw divide the original problems into smaller subproblems and then store the result and find the result individually and store that result, then reuse stored result whenever needed. So properties of DP means overlapping subproblems and optimal substructure. So the same problem appears multiple times, that is called overlapping subproblems. So optimal substructure means optimal solution of the main problem can be constructed from optimal solution of the subproblems. So each subproblem solutions are very important here. So these are the advantages of a DP, dynamic programming. So first is reduce repeated calculation, right? So no need to calculate the same function again and again. We store the values and reuse it. Then faster, so for the execution will be fast. That improves time complexity and efficient for recursive problems. So here two approaches is there in dynamic programming. One is top-down approach, that is called memorization. Another one topic is bottom-up, that is called tabulation. So top-down approach means uses recursion and stores computer result in memory. Okay. So here bottom-up approach is started from the smallest subproblem and builds solution step by step. That is called tabulation method. If the tree is constructed means the solution started from the leaf node of the tree. Okay. Application of the DP, dynamic programming. These are the applications. Fibonacci series, we find those problems easily using DP method. Fibonacci numbers, knapsack problem, matrix chain multiplication, shortest path, and LCS, longest common subsequence. Okay, here we discuss the first application, that is Fibonacci series. So what is Fibonacci? We know that, right? If just calculate previous two values and give one new value. So if you find f of 5 means Fibonacci of 5 means we calculate the new value by add two previous values till the value reach 5. So this is the Fibonacci series. So initial start from 0, then 1, 0 plus 1. So these are the base condition. We know these two values we need these two values. This is the base condition f of 0 and f of 1. Then perform the add operation. 0 plus 1, 1. Then 1 plus 1, 2. Then 1 plus 2, 3. So we simply add previous two values and get the next value. That is called Fibonacci series. That is called Fibonacci series. Clear? So this is the formula. So we need f of n means we simply add previous two values f of n minus 1 plus f of n minus 2. These are the base condition. If the n value is less than or equal to 1, then simply return the value 0 or 1. Okay, so normal recursion problem in Fibonacci means this is recursion function is called, right? So initially we call one function, the Fibonacci function is f of n minus 2 and f of n minus 1. So f of n equal to f of n minus 2 plus f of n minus 1. So we call two functions. This is recursive method. So initially the f of 5 is divided into f of 4 and f of 3, right? Not f of 2, f of 3. Mistake is there. So here f of n minus 1, right? Here f of n minus 1, that f of 4, and here f of n minus 2, that is f of 3. Likewise split all the values till the tree reached 0 and 1. Some edges are missed here. So reach. So this is the base condition. So the function divide again and again, still reach the base condition 0 and 1, f of 0 and f of 1. If you reach the value f of 0 and f of 1, then return that value, right? So this is the normal recursion method. What will happen here? First we need to find the value f of 0. How many times we need to find f of 0 value? Here f of 0 is there. Here f of 0 is there. Here f of 0 is there. So 3 times we need to calculate the same function again and again. Likewise f of 1 here, here, here. F of 2. So many times the same function appeared here, right? So these are the unwanted calculations, right? So in this is normal recursive method, but in DP we have two approaches there. One is top down, one is bottom up. Top down is called memorization, bottom up in tabulation. So in what is the memorization method? So memorization method not mentioned in this slide, but I will explain what is memorization. Memorization means memorization used in the recursive function only, but here normal recursion method we need to calculate the same value again and again, right? But in memorization, one times we calculate the value f of 0, they stored in the memory. One array is there, we store this calculated value here. So what is the initial value of f of 0? That is 0. Then store that 0 in memory, right? Then again find f of 1 value, that value is stored in memory. So don't use again and again. So again we need to calculate f of 0 means no need to calculate again, just take the value from the memory, right? So likewise every time you calculate one new function and store inside the memory and use that value. So this is called a memorization method. So this is top down approach. So another one approach is there, that is tabulation. So in normally DP method using tabulation method than memorization. Okay, in DP tabulation is best. Okay, so now we will discuss what is tabulation in Fibonacci. So Fibonacci using dynamic programming, normally in tabulation method is used here. Okay, here in programming, initial step is just check the particular number is 0 or 1. If the number is less than or equal to n, simply return the n value. So this is okay. Otherwise, if the n value is greater than 1 means, initially we store two base values inside the table. One DP table is made, dynamic programming table is maintained here. Initial two values simply stored in the table, f of 0 equal to 0 and f of 1 equal to 1. Okay, then calculating only one simple for loop is used here. No function is used. Simple for loop is used here. Inside the for loop, simply give that formula f of n equal to f of n minus 1 plus f of n minus 2. In this calculation, you no need to calculate the value f of 0 and f of 1 because we already have that value in table, right? So just take the value and add it. Here the for loop start from 2, I equal to 2. So we need to calculate f of 2 means we need these two values, f of n minus 2 and f of n minus 1. We need f of 0 and f of 1, right? So already these two values in the table. So just take the value from the table and add it and find the new value f of 2. So that new value also stored in the table for the future use. Clear? Then we need to calculate f of 3 means simply add previous two values f of 1 and f of 2 and find the value 2. This value also stored in the table. And f of 4 means simply add two previous values and get the result. Likewise you find all the results and stored in this table. This is very simple method compared than normal recursive method. So now we will discuss the time complexity of two methods. So normal recursion we take 2 power n. So order of 2 power n time complexity, but in dynamic programming only take order of n. Dynamic programming improves efficiency by storing previously completed results, right? Previously completed result and reusing them whenever needed. No need to calculate the same function again and again. So just maintain one table and store the values, calculated values inside the table. That values are used for the future calculation. This is the dynamic programming. It's a powerful technique for solving optimization problems efficiently. Thank you.